Hello, this section 3.4 is titled Addition and Subtraction Algorithms, Mental Computation and Estimation. Now, this section talks a lot about things that I'm not going to focus on. They talk about using different manipulatives to teach addition, and we all know, of course, that this has to happen for small children. I mean, they have to learn how to start using counters and putting two things with three more things, and then counting them up to get five things. Base 10 blocks they use in elementary schools. And I understand the need for those so that students can get hands on learning with it. But there is nothing that beats old fashioned drills. I know that they're not fun, and I know that students kind of complain about them, and probably even teachers hate them, but your students must know how to add, subtract, multiply, and divide single digit numbers. Well, dividing and would be more than single digit numbers, but they absolutely have to know how to add, subtract, and multiply single digit numbers off the top of their heads. If they learn to do that, then it will make everything else that they do in math so much easier for them. So, I mean, you just think about it. You know, how in the world can you do factoring where you're asked to figure out two things that multiply together to get some number, but add or subtract to get another number if you are not just completely fluent with single digit multiplication and addition or subtraction? So it's necessary. I know it's not fun, but it is necessary. It absolutely will help with everything that they do from that point forward. So I'm not going to focus on the manipulatives and all of that. I mean, I think you guys can do most of that stuff. It's very elementary. And I want to talk about what they call mental computation and estimation for just a minute. I understand the need for estimation. The problem is that so many schools will tell students to estimate, 94 plus 15. And if they say 100, then they may count it wrong, and they say, no, it should have been 110 or 120. Well, that is just flat wrong. That is something that we do to students that creates that fear of math in them because they feel like that they have to have the absolute correct answer even with estimation. And the very nature of estimation is that it's a ballpark figure. So if you're estimating that it's going to be a little over 100 for 94 plus 15, then you're correct in giving your estimate. Now, if you say 10, then you would quite obviously be incorrect in your estimate. But, as long as they're in the general ballpark, then it is correct. So I don't like doing estimation problems where there is a right or a wrong answer. Now, that is unless you give them a specific digit to round to or a place value to round to. If you tell a student round these numbers to the nearest tens and then estimate the answer, that would be perfectly reasonable to do. But that does require a little bit more of a higher order thinking skill. So just be very conscious when you're designing your lesson plans and what you want to do that you are not damaging their abilities from then on by creating a situation where even with guesstimates that they would be wrong, because that's not fair at all. So be careful for that. Now, what I am going to focus on in this section is learning how to add and subtract in other base systems. I think that that will be very beneficial to you as an instructor, because if you can add and subtract in other base systems, then you really know our base 10 system. So, and you're able to maybe explain and help students to understand it better if you have a deeper knowledge of it. Okay, so let's just start off with our own base 10 system. Okay, so what would we normally do if we saw a problem like this? This one says 375 plus 492. So normally we would, if we were going to add this, we would just say, well, okay, 5 plus 2, well, that's 7. 7 plus 9, well, that's 16, so we just carry the 1. 4 plus 3 is 7, plus 1 is 8, so it'd be 867. True? Okay, but I want you to think about what's going on here. Since we work in a base 10 system, then that means that we're working in groups of 10. So this is the ones place value, this is the tens place value, and this is the hundreds place value. Those are all powers of 10. This place value is 10 to the 0, this place value is 10 to the first, and this place value is 10 squared, and it just goes up from there. Okay, another thing, since we're working in base 10 system, is that we can only use 10 digits. Then we have to move to double digits. So the only digits we can use are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. When we get higher than that, now we're talking about a group of 10, which is another digit. So, because that's another place value. So I want you, well, let's go back and let's add this again, but keep in mind what's really going on. Okay, here we're adding ones. 5 ones plus 2 ones is 7 ones. That's true. This 7 and this 9, though, those are groups of 10. So we technically have 16 groups of 10. Well, in the number 16, there is one group of 10 and 6 singles, if you think about it that way. Or if you think about it as truly being groups of 10, 16 groups of 10 would be, what, 1600? Or, whoops, I'm sorry, 160. Whoops. It's a little early in the morning and I'm still not awake. So 160. So that would actually be a group of 100, which is this place value, and then 6 tens, which is this place value. So it's easier to look at it as 7 plus 9 is 16, which is one group of 10 and 6 singles. Now then over here, this is the hundreds column. So we would have 4 hundreds plus 3 hundreds plus 100 would be 8 hundreds in that position. So that is what's really going on. Now with addition, it's not near as difficult for students to understand as it is with subtraction. And I know that I have been guilty of doing this also. When we learn to do subtraction, and especially when we learn to teach it, we just tell students, well, you can't take 8 from 2, so you have to borrow here and change that to an 8 and add the 1. Well, that's great and fine, but the problem comes when you have them do, I don't know, something like, say, 2 1/5 minus 1 2/5, because at this point you can't just cancel it out and put a 1 there. That's not valid. So we can't teach it that way. Otherwise they won't understand what's really going on. So let me erase this and let's think about what's happening here. it's true that you cannot take 8 from 2 because these are singles. So we're going to borrow here. But remember, this is a group of 10. So now I'm going to have 8 tens instead of 9 tens, and I'm going to have to add that 10 to the single digits. So 2 singles plus 10 of them would now technically be 12. That's why you're putting the 1 there. But I want you to understand why it's happening and not just do it rotely without thinking about it. Now we can take 8 singles away from 12 singles, and that would leave us with 4. Moving over to the next column, we can take 4 from 8, and that would be 4. And we can take 2 from 4, and that would be 2. So our answer would be 244. Now, just for a second, let's go back to that problem that I wrote originally. That 2 1/5 minus 1 2/5. It's the same idea. So if they learn it, instead of just, canceling it out and putting the 1, if they learn it properly, then when they get to something like this, they can understand better, because we can't take 2/5 from 1/5. 2/5 is larger. So we would have to borrow 1 from this 2, but we would have to turn it into a fractional amount. So we're borrowing 1. Well, 1 is 5/5. So when you add 1/5 plus 5/5, you actually have 6/5. And then we can take 6/5 minus 2/5, which would be 4/5. And we can take 1 from 1, which would be 0. So our answer would be 4/5. It will make their transition to learning to add and subtract fractions, variables, all of that much easier if you teach it properly the first time.